In this video, we're going to look at randomness. The notion of randomness is needed whenever you need to write a game of chance, for example. Now, we're not going to get too technical about the definition of randomness, but if you want to know more about the technical side of randomness, there are many resources online, and one of them is random.org. If you do a Google search on how to write a random number generator in C or Java or JavaScript, you'll get lots of hits, and there's a standard way to do it. Okay, so let's look at some code here, and this is a C code. You don't really have to worry about these lines here, and the key is this program. If I run this, it will do the following. So it will wait for a character. So if you press a character, it will check if it is a queue. If it is a queue, it will quit the program. Otherwise, it will make a virtual coin toss. Alright, so if I do it 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those are the values that the program returns. And here is what I mean by the standard way. So in C, you can call this function called rand to give you a random integer. And if you do modulo 2, it will give you the remainder when divided by 2. So R is either 0 or 1. And it's supposed to be random because rand gives you a random integer. Right? All is well. And now, what is this thing here? Well, this rand function is actually a pseudo number generator. What that means is it is not really random. And here's what I mean. Okay? So I'm going to run a different version of this program without this line here. And you'll see that something strange is going to happen. So let me do this 20 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And I'm going to run this program again somewhere else, okay, on a different terminal. And I'm going to make 20 virtual coin tosses. 1, 2, 3, 4, 5. Now, just look at the two. They are exactly the same, even though the sequence looks unpredictable. Well, and the problem is this, because this is not a this is not a true random number generator. It's a pseudo number generator. What that means is when you start the program, it begins at a particular state. Every time you call rand, it moves to the next state, and that's how it gets the next value. Now, the process is deterministic. Given a current state, the next state is determined. It just gives you an illusion of unpredictability. And in order to get around that, we have to change the initial state. And one way to do it is to use the time function. So when you run the program, the time is different, right? So presumably you will start at a different time, so the initial state will be different every time you run. And so the sequence of random numbers will be different. So if you comment this out and compile this, you'll get the version that will give you the same sequence every time you launch. So that's not very nice. And the standard way, as I said, to get around this pseudo number generator problem is to start with a different state. And the most convenient way of doing that is to use the system time as the random seed. So srand specifies the random seed. We are now going to look at a different way of doing this virtual coin toss. This is a rather unusual way, and there's some interesting properties about this. So here I want you to focus on this part here. In fact, just these two lines. So here I don't use the rand function anymore, but I do use something called get time of day, and it fills in some value into the structure TP. TP is a time value structure. It has a field called TV_USEC, and in fact it is the microsecond field of the system time. Think about that. A microsecond is 1/1,000,000th of a second. And why would this give us something random? Well, here's the thing. When you are accepting an input, you can't really be sure, what's the parity of the microsecond, right? Because the clock goes by so fast. It's not humanly possible to game this system, right? Because I cannot time my input so well that can control the parity of the microsecond field. Okay, and in this, that's the case. Let me just run this program. And this time I'm going to make 40 virtual coin tosses. Okay, as you can see, it looks pretty random, right? It looks like a rather unpredictable sequence. And if I keep going, there's no way you can really predict what comes next. So all is well, right? So you might want to use this as, say, a binary random number generator. And now I'm going to show you why this is not a good idea. So I'm going to show you a different program. And this time is a bit more complicated. What this thing does is the following. It will generate 9,000 random binary numbers. And depending on your options, so it will ask you if you want to use rand for that. If not, it will go through this loop. This loop is going to fill the array with random binary numbers obtained by this method. Okay, the second method, the method over here on the left hand side, same thing. Okay, and at the end, it's going to print them out, and it's going to count the number of ones, and there will be 30 numbers per line. Okay, so I'm going to run this with both options. Okay, so let's see. So this first time I'm going to use rand. All right, so 4,582 ones over 9,000 numbers generated. And here I'm not going to use rand. Okay, and 4,501 ones among 9,000 numbers generated. Now, if you look at the left, the sequence is pretty random, right? Pretty unpredictable. But what's going on here on the right? Well, you see here a sequence of ones followed by a sequence of zeros, and then followed by a sequence of ones, and then followed by a sequence of zeros, and so on. It looks like there is a repeating pattern. It doesn't look that random compared to the first time, compared to the program that we had seen before. Right? With this program, every time we press the key, we seem to be able to get a random binary number. But here it's no longer the case. Why is that? I encourage you to pause the video and think about this. Now let's look at this more carefully and see why that is the case. The key is this loop here. Now remember that we are getting the time of day, the microsecond field, to get our random number. Now why is that not a good idea? Well, imagine that this loop gets executed very quickly. The fact is, our computers are very fast now. It can execute billions of instructions per second. It is conceivable that within a single microsecond, it calls this time of the day 10 times per microsecond. And if it does that, then you will have a string of 10 ones or 10 zeros. And it looks like this is the case, right? In fact, we get more than 10, a string of 10 ones. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, more than 20. This string is more than 20 ones. In light of this, using this method, get time of day, looking at the microsecond field, is not going to give you a good approximation of randomness. At least in this context. Okay, if you're going to generate these random numbers very quickly, this is not a good idea. But if you are going to accept user input every time you generate something, it looks to be good enough. So I hope from this video, you see that generating random numbers is a tricky business.